Hello everyone, welcome to this tutorial on orbital overlap in GChemPaint. In this tutorial, we will learn about different types of orbitals, rotation and resize of orbitals, types of orbital overlaps. Here I am using Ubuntu Linux OS version 12.04, GChemPaint version 0.12.10. To follow this tutorial, you should be familiar with GChemPaint Chemical Structure Editor. If not, for relevant tutorials, please visit our website. Let us first see what an atomic orbital is. An atomic orbital is a mathematical function. It describes the wave-like behavior of an electron in an atom. An orbital is a region of space with maximum probability of finding an electron. This is an s orbital. It has spherical shape. Here are p orbitals in different axes. P orbitals are dumbbell shaped. Next we have d orbitals in different axes. D orbitals are double dumbbell shaped. I have opened a new GChemPaint application. Let us first learn about orbitals. Click on Add or Modify an Atomic Orbital tool. Orbital property window opens. This window contains fields like coefficient, rotation and type. First I will begin with type. By default s orbital is selected. Let us click on p, dxy and dz² orbital radio buttons. Notice the different orbital shapes displayed alongside. Next, let us check the coefficient and rotation properties. Coefficient property has values from -1 to 1. Using coefficient field values, we can vary the size of the orbital. Notice that the size of the orbital alongside has changed. Rotation property has values from -180 to 180. We can rotate the orbitals clockwise or anti-clockwise. Values can be changed by using up or down arrows. Let us see how to use orbitals to show different types of positive overlaps. Here is a slide for positive overlap of different orbitals. SS overlap, SP overlap, PP overlap, and PP sidewise overlap. Let us draw hydrogen molecule on the display area. Press H on the keyboard. Set the coefficient value to 1. Click on Add or Modify an Atom tool. Click on Add a Bond tool. Ensure that bond length is around 130. Click on the display area. Hydrogen molecule is formed. Let us start with SS end-on overlap. Click on Add or Modify an Atomic Orbital tool. Click on the s orbital. Then click on hydrogen atoms of the hydrogen molecule. Observe SS end-on overlap. Now to PP end-on overlap. Press F on the keyboard. Click on Add or Modify an Atom tool. Click on Add a Bond tool. Ensure that bond length is around 200. Click on the display area. Fluorine molecule is formed. Click on Add or Modify an Atomic Orbital tool. Click on the p orbital. To form PP end-on overlap, we need p orbitals in horizontal direction. Let us increase the rotation value to 90. Click on the p orbital. Click on one fluorine atom. Likewise, repeat the process and rotate the p orbital to -90. Click on the other fluorine atom. In case you are not able to view the orbital clearly, you can resize the orbital. To do so, we have to change the coefficient value. Right-click on the orbital, select Orbital and click on Properties. Orbital Properties dialog box opens. Reduce the coefficient value till you see a proper overlap. Click on Close button. I will repeat the process for the other orbital. Observe PP end-on overlap. Now to DD end-on overlap using dz² orbital. Come to the display area and press capital F on the keyboard. Select Fe from the list. Click on Add or Modify an Atom tool. Click on the display area. Click on Add a Bond tool. Click on Ion Atom to draw a bond. Click on Add or Modify an Atomic Orbital tool. Select dz² orbital radio button. For proper overlap, decrease the coefficient value to 0.8. Click on the bonded ion atoms to overlap dz² orbitals. Observe DD end-on overlap. Now let us learn about sidewise overlap of p orbitals. Ensure that current element is carbon. Click on Add a Bond tool. Ensure bond length is around 90. Click on the display area. Click on Add or Modify an Atomic Orbital tool. Increase the coefficient value to 1. Click on p orbital radio button. Rotate the p orbital to vertical position if it is in horizontal position. Click on the edges of the bonds. Observe PP sidewise overlap. In this type of overlap, lobes of orbitals are of same sign. Next we will move to negative and zero overlaps. Here is a slide for negative overlaps. I have opened a new GChemPaint application. Now I will demonstrate how to draw a negative overlap. Click on Add a Bond tool. Ensure that bond length is around 90. Click on the display area. Click on Add or Modify an Atomic Orbital tool. Click on the p orbital radio button. Then click on one edge of the bond. Rotate the p orbital to 180 degree to flip it upside down. Then click on other edge of the bond. Observe negative overlap. In this type of overlap, lobes of orbitals are of opposite sign. Now let us learn how to create a zero overlap. Here is a slide for zero overlap. Click on Add a Bond tool. Click on the display area. Click on Add or Modify an Atomic Orbital tool. Click on the p orbital. Rotate the p orbital to original position. Click on one edge of the bond. Click on s orbital and then click on other edge of the bond. Observe zero overlap. In this type of overlap, orientation of the orbitals is not same. Let us summarize what we have learned. In this tutorial, we have learned about different types of orbitals, end-on and sidewise overlaps, rotation and resize of orbitals, positive, negative and zero overlaps. Here is an assignment. Draw sp end-on overlap with hydrogen chloride molecule. Draw sidewise overlap of dxy orbitals. Draw other negative and zero overlaps. Hint: rotate and resize the orbitals for proper overlap. Your completed assignment should look like this. Watch the video available at this URL. It summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials, gives certificates to those who pass an online test. For more details, please write to contact@spoken-tutorial.org. Spoken Tutorial project is a part of the Talk to a Teacher project. It is supported by the National Mission on Education through ICT MHRD, Government of India. More information on this mission is available at this link. Drawings are contributed by Aarti. This is Madhuri Ganpati from IIT Bombay signing off. Thank you for joining.